Hello to all you brave souls who decided you wanted to see the answers to the free response questions on the BC test. So we're going to go through these one by one. I've already written most of the stuff down. I will add to it as we go. Not really going to do much demonstration of the calculator button pressings because I think you guys know what to do. If I get to a point I feel like I need it, I can just pull it out and show you. So we have our first question. Fish enter a lake at a rate modeled by the function e of t as the enter and the leaving the lake as L of t, and that's so it's an in and out function. Both e and t and L of t are measured in fish per hour. T is measured in hours since midnight, so that makes it a little bit easier to do the calculations. First question, how many fish enter the lake over the 5-hour period from midnight to 5 a.m.? And they're really helpful. They tell you t equals 0 to t equals 5. Give your answer to the nearest whole number. Now, because we haven't decided on the grading scale yet, or the people who do that haven't done it, last year, if you forgot to round it, they didn't count off, but they prefer that you do because it's only asking for how many fish enter. We're going to integrate 0 to 5 of e of t dt, which comes out to be 153 fish. Question 2, what is the average number of fish that leave the lake? Average number of fish that leave the lake per hour over the 5-hour period. So if you're going to average something, you've got to add up how many there are and then divide by how much time has gone by per hour. So it ends up being an average value, because average value is 1 over b minus a, which is your division by the total, and then adding them up. Now, if you didn't set it up as an average value problem, that's probably going to be okay, as long as you integrated from 0 to 5 and then divided your answer by 5. Now, this one did not say round to the nearest whole number, so the decimal answer is 6.059 fish per hour if you put it in the calculator. All right. So for this one, at what time t from 0 to 8 is the greatest number of fish in the lake, and justify. So that is an absolute maximum because of the fact it's a closed interval and because it doesn't say relative. So we're wanting the maximum volume of fish in the lake is what we're looking for. So we have to construct a volume formula, which happens to be e of x minus L of x dx. And when you then take the derivative of that, it's the integral from 0 to t, because I don't know when the volume is the biggest. And also because we're getting a formula that works for any time between 0 and 8. So when you take the derivative of v, you get v prime equals, and the second fundamental theorem of calculus tells you that's going to be e of t minus L of t, and you set that equal to 0. And when you do it on the calculator, you put that in the calculator and do your crossing, it comes out to be 6.204. Now, v prime does not fail. I forgot to write that down. I don't think they count off if you forget to write it down, so I don't think that's a big important thing. The endpoints are 0 and 8. We then go ahead and create the t-chart over here. Remember that you're plugging into v, which is the integral. So these numbers become the limits of integration. 0 to 0, which of course is 0, 0 to 6.204, which comes out to be 135, and 6 from 0 to 8 comes out to be 81. I rounded those to the nearest whole number because we're talking about how many fish there are. And the question says, at what time t? I went ahead and answered it both ways. It happens to be the 6.204. Actually, no, I did not. I take that back. The maximum number of fish are in the lake at time 6 equals 204. Just now realized that I needed to put hours, and I believe it said at what time. So, or you could say that is approximately 6 a.m. Now, I don't know how picky they're going to be on the AP test, because usually when they say at what time, they will actually want a time of day. So 2 hours into, 0.2 hours into an hour, 1/5 of 60 is, I'm doing this on the fly, is 12 minutes. So it's probably 6:12 a.m. if you wanted to be picky about it. Like I said, I don't know if they want 6:12 a.m., if they want 6.204. I don't know how they're going to grade that at this point. If you went all the way and found 6:12 a.m., good for you. All right, part D. Here, this one was tricky, and this is the one I was talking about in class that I actually missed the first time I did it. It says, is the rate of change in the number of fish in the lake increasing or decreasing at time 5, explain why. Now, it's asking, is the V prime, is the rate of change of the fish, the number of fish, increasing or decreasing? And that actually means, is V double prime positive or negative? That's what we're really wanting to know. So what you must do is you must take the double prime, which happens to be E prime minus L prime. If you stored Y3 as your V double prime, as your V prime, you could do a math 8, or you could just put in your E prime. You would have to do actually a math 8 on both of those. You would do a math 8 at 5 for the first equation minus the math 8 at 5 for the second equation. It comes out to be negative. And since V double prime is negative, this means that V prime of 5 is decreasing. So if you just say V prime of 5 is decreasing, I think that would be okay. I think a better answer, the rate of change of the number of fish is decreasing. That's actually answering the question better than what I just said. All right, so that's the end of number 1. Moving on to number 2. This is that funky looking graph one. So we have S is the region bounded by this polar curve, which kind of looks like a flower, from 0 to the square root of pi as shown above. So the square root of pi is how far you have to go before it creates an entire region. Find the area, first thing they want. So the formula for area, which a lot of people missed on the performance final, they forgot the 1/2. So it's 1/2 0 to square root of pi of r of theta squared d theta, or you could have put the equation in there, put squared. When you put it in the calculator, you get 3.534. It's a pretty straightforward problem. You just had to remember the formula correctly. Number 2, what is the, whoops, give me a minute. Come on. What is the average distance from the origin to a point on the polar curve for 0 to the square root of pi? So that distance from the origin to the polar is how it graphs the curve. It's the distance out. So that's basically the radius. So you're finding the distance, you're finding the value of the curve at that point. So what it is an average value scenario, which is 1 over b minus a integral from a to b of r of theta d theta, which comes out to be 1.579. So moving on to letter C. Letter C was a little tricky. Let me move it down so you can see it. There is a line through the origin with a positive slope of m, which divides the region S into 2 regions with equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of m. All right, so the way that I like to do this, it says it's dividing it into 2 equal areas. So we already know what the area of the whole thing is, so we find half the area. So we take that area answer we got in part A, we divide it by 2, and we get 1.767. So your initial thought would be, oh, I just do the integral from 0 to a, and then from a to the end, or 0 to m, excuse me. But that doesn't work because the limits of integration must be angles. So what we must do is think about the slope of a line in comparison to the angles that it creates. So what we have to do is come up with a formula that the tangent of, I'm going to call it angle B, is equal to m, because slope is the tangent, the opposite over the adjacent, the rise over the run. So what you do now is you solve for b and you get tangent inverse of m, and you will write your equation. You can write it that way now. 1/2 the integral from 0 to b of r of theta squared d theta is going to equal half that area. So you're still using the area formula, You have defined b to be the tangent inverse of m. Even though m is not in my formula, I can write it this way. If you had written 1/2 from 0 to the tangent inverse of m, that works as well. It gives you the same answer. But since I defined b to be the tangent inverse of m, officially m is part of my equation, and that is an acceptable answer. So that takes care of part C. For part D, for k equals 0, let a of k be the area of the portion of region S that is also inside the circle, r equals k cosine of theta. Find the limit as k approaches infinity of a of k. That probably, this question, if more than others, probably scared you the most, because it's got a limit and it's got a polar, and you're just thinking, what's going on here? So what's happening is any equation k cosine of theta happens to be, and I'm going to go ahead and put this on the screen. So give me just a second. I just decided I wanted to do this. So if you look at this, it's k cosine of theta. So what I did is on this problem, since we have a calculator, I played with it a little bit. This is the way I did it, 2 cosine theta. What does that look like? Zoom 4. Okay, now it's only going from the 0 to square root of pi. I set my window that way already. If I now change my equation to be like 5 cosine theta, what does it do? It makes a bigger circle. If I change it to 10 cosine theta, because I'm making k approach infinity. K is the coefficient in front of cosine. I'm going to have to do a zoom 6 now so you can see it. I know I'm off the screen just a little bit, but you get the idea that the larger you go, the bigger the circle gets. So I'm going to go as big as 20. Look at this circle. It's huge. So compare that to the equation, that little petal that it drew. It's eventually going to get to the point where this side of the graph is pretty much flush against the y-axis. As k gets bigger and bigger and bigger, it's just going to get wider and wider as you get closer to the y-axis. So the only part of the graph, the initial graph, that's not going to be in the circle is the part that's in quadrant 2. So if you go back and look at your graph, or I'll go back and show it to you, the only part that is not going to be inside the circle is this little piece in quadrant 2 right there. So the circle will eventually get so big it encompasses this entire thing, just not that little bit. Now, what is the angle right there? The angle happens to be pi over 2. So that tells me that when I set up my integral, as k approaches infinity, the circle will fill quadrants 1 and 4, so only the part in quadrant 2 will not be included. So the limit is going to be the area of just the part of the curve that is in quadrant 1, which is with the part that goes from 0 to pi over 2. And you can set your window to show you that it's going to be that little bit, and graph it out, and you will see that it's approximately 3.324. All right, so that takes care of number 2. Moving on to the no calculator part, number 3. So we have this piecewise function here. We have a straight line, and a part of a quarter of a circle. And that's very important later on. It's centered at the point 5, 3, so my quarter circle center is right there. It is known that the point 3, 3 minus root 5 is on the graph of f. You're going to need that later. Remember, I told you every time you see something, you're going to need it later. So the question says, if the area from -6 to 5 under this curve is 7, what's the area from -6 to -2? Now, a bunch of people at this point panicked. Wait a minute, my graph doesn't go all the way to -6. I don't know what to do. But if you extended your graph out, -3, -4, -5, -6. Here's -6. So the area from -6 all the way to the end is 7. I'm trying to find the area from -6 to -2. Well, I can find the area from -2 to 5, so I just subtract that from 7. So what I did is I built a math sentence, basically, that said the area from -6 to 5 is equal to the area from -6 to -2, which is what I'm solving for, plus the area from -2 to 5. So then it was time to sit down and figure out what this area actually is. Now this is how I went about it. This piece here and this piece here cancel each other out. I'm trying to find the area all the way across, so I just ignore that. This little triangle here and this little triangle here also cancel each other out. So the area is actually only from 1 to 5. So from 1 to 2, I have a trapezoid. Height of 1, this base is 1, this base is 3. So if you do the area of that, add the bases is 4, times the height is 1, and take half of it, the area of this trapezoid right here is 2. Okay, now we have this curvy, weird looking piece right here. How do we do that? Well, what we have to do is we actually have to take and make this into a square, which is 9 units big, and subtract off the circle, which will leave that. So that's how I set up this problem. So come down here. -6 to 5 was 7. This is what I'm solving for. This came out to be, this is the triangle one, or the trapezoid, 1/2 the base and the sum of the heights. And then that area formed by the quarter circle is 9 minus 1/4 of pi radius squared, the radius being 3. Okay, so when you bring this down, after solving for the integral that I don't know, bring everything else to the other side. So it's 7 minus 2 minus 9 plus 9 pi over 4, because when it comes over it changes sign, so it's -4 plus 9 pi over 4. That is the area of from -6 to -2. Letter B. Evaluate the integral from 3 to 5 of 2f prime of x plus 4. We did so many of these problems before the AP exam, where I told you that if you see an f inside an integral and then they add a 4 or something, you got to break it apart. So step 1, break it apart and pull the 2 out. So when you pull the 2 out, you're pulling it just out of the f prime, and then I have the integral from 3 to 5 of 4. The 4 could come out now, but it can't come to the very front. So the antiderivative of f prime is f, and the antiderivative of 4 is 4x. So this becomes 2f of x from 3 to 5, 4x from 3 to 5. Then you start plugging in your values. 2f of 5 minus 2f of 3 plus 20 minus 12. Do the math, plugging in the values. F of 5 is 0. And f of 3, they told you in the reading part, that was the 3 minus root 5. And then the area of these two together makes 8. Clean it all up. If you clean your answer up, it comes out to be 2 plus 2 root 5. If you left your answer right here, that would have been totally acceptable. You didn't have to clean it up. Okay, now on to question C, excuse me. The function g is given by the integral from -2 to x of f of t dt. In other words, the area under the curve from -2 to x. Find the absolute maximum value of g on the interval and justify. So I went ahead and brought over a copy of the graph. So g is that function. So g prime is equal to f of x, which you're supposed to set equal to 0. And if you look at the graph, you will notice that it equals 0 at -1, 1/2, and 5. So those are your 3 critical points from there. G prime does not fail. There are no holes in the graph of g prime, which is f. The endpoints are -2 and 5, so we use all of those points on our chart. And the chart is basically, remember, the area from -2 to the right. So at -2, the area is 0, of course. At -1, the area of that triangle is 1/2. The area up to 1/2, these two, remember we said crossed out. So this area here is all that's left. That's -1/4. And then the area up to 5, we already figured out as -4 plus 9 pi over 4 from a previous problem. So the maximum value of g is that y value. It's -4 plus 9 pi over 4, which does occur at x equals 5. All right, so now to part D. Part D just says find the limit. Now, on first glance, hopefully you notice that if you plug in 1 for x on the first term, you're going to get 10. And I'm thinking it's not going to be a 0 over 0. I'm just thinking that off the bat. So we got to just plug in and see what happens. So when you plug in, you get 10 to the first minus 3f prime of 1 over f of 1 minus arctan of 1. So f prime of 1, remember this is the graph of f. F prime of 1 is the slope at 1, and the slope of this line happens to be up to and over 1. So f prime of 1 is 2, and f of 1 is 1. So when we go back to here, we plug in 2 for f prime of 1, because that is the slope at 1. F of 1 is 1, that's the y value at 1. The arctan of 1 is pi over 4, and you clean it up, and you get 4 over 1 minus pi over 4. That's as far as you need to go as far as cleanup is concerned. So that is the answer to that part. So now moving on to number 4, the cylinder problem. Cylinder barrel with a diameter of 2 collects rainwater as shown in the figure. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of height h of the water in the barrel with respect to time is given by this differential equation right here. dHdt equals negative 1/10 square root of h. H is in feet, t is in seconds. They gave you the volume of a cylinder, which amazed me that they actually gave that to you. So find the rate of change of the volume of the water in the barrel with respect to time when the height is 4. So the volume formula is here. R is a constant and it's equal to 1. So you can plug that in immediately. No matter how full the barrel is, it's always going to have a radius of 1. So that can be plugged in right away. The question asks us to find dV dt when h equals 4. So our formula just changes to pi h, makes it a lot simpler. If you left the r in there, you will find that dr dt is 0, and what will happen is when you do product rule, the dr dt term will disappear. If you did what I did and just got rid of the r right away, you end up with dv dt equals pi times dh dt. dh dt happens to be its formula, negative 1/10 square root of h. And they want you to evaluate it when h equals 4. So dV dt when h equals 4 is pi times negative 1/10 times the square root of 4, which is 2, which is negative 1/5 pi. And they said indicate units of measure. That means a point will be accounted for the label. Or they will only give you credit for the answer if you label it. That's usually the two ways they handle that. So negative 1/5 pi cubic feet per second. All right, letter B, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? This is just like number 1. They want to know if the rate of change of the height of the water, in other words, dH dt, increasing or decreasing, which at the same time means is the second derivative positive or negative. So what you do is you take the second derivative, which is negative 1/10 times the derivative of the square root of h, which is 1/2 h to the negative 1/2, times dH dt, because you're taking the derivative of an h on this side. So it's like taking the derivative of a y. So then you clean up the left-hand part, which is negative 1 over 20 root h, and then it's negative 1/10, because you substitute back in what dH dt is. The square root of h's cancel out, so you end up with a positive 1 over 200, which is always positive. So since the double prime is positive, that means h prime is increasing. And so since d squared h over dt squared is positive, dH dt is increasing, and you can't see what I'm pointing at. There we go. Since the second derivative is positive, dH dt is increasing when h equals 3. It's actually increasing all the time. All right, moving on. So letter C, make it a little bigger. At time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So they kind of even tell you what to do. Separation of variables means you start out with the original problem, which happens to be in red. You move things around. The dt moves to the other side. divide both sides by the square root of h, so you get dh over the square root of h equals negative 1/10 dt. Then it's time to integrate both sides. I went ahead and rewrote the left-hand side, bringing up the h because it's not an ln, because the power is not 1. So h to the negative 1/2 dh equals negative 1/10 dt. Raising the power, you get 2h to the 1/2. The left side, on the right side, is negative 1/10 t plus c. This one does not need the e thing. We immediately plug in the 0 and 5. We get 2 root 5 equals negative 1/10 times 0 plus c. c equals 2 root 5. Now, if you chose to solve for h before you plugged in the 0 and 5, that's fine. Your c will be slightly different. But in the final answer, our answers should match. So going back to right before I plugged in the 0 and 5, which is this line right here, I went ahead and plugged in c to be 2 root 5. Now I need to solve for h because it says h in terms of t. So we divide both sides by 2, which makes negative 1/20th t plus root 5. Then we go ahead and square both sides. You cannot square individual terms. You leave it as all one quantity, negative 1/20th t plus root 5, the quantity squared, and that is your answer. So that is number 4. So moving on to number 5. Number 5 was a little bit unusual. This one I think is going to probably have one of the lower scores as far as the grading rubric goes, but I won't know till we go grade these tests. Consider the family of functions y equals f of x equals 1 over x squared minus 2x plus k. To find the value of k for k greater than 0 such the slope of the line tangent to the graph of f of x at 0 equals 6. So that basically is saying find k when f prime of 0 equals 6. Slope of a tangent line is the derivative. So what we do is we plug in, we first take the derivative, which would be a negative 1 x squared plus, minus 2x plus k to the negative 2, and then the derivative of the top is 2x minus 2, which puts negative quantity 2x minus 2 over the bottom squared. So the slope at 0 should equal 6. So that means we plug in 0 for x, which makes there be a positive 2 on top because it's a negative negative 2. And then 0 on the bottom leaves k squared equals 6. Solve for k. So k squared equals 1/3, and k equals the positive square root of 1/3. It is not plus or minus because it says in the problem that k is greater than 0. All right. Part B, if k equals negative 8, find the value from 0 to 1 of f of x dx. So when you write the integral, you get x squared minus 2x minus 8, which factors into minus 4 and plus 2, which means we need to separate the variables. Remember the separate the variables procedure. You figure out what makes the bottom equal 0. That would be a 4. You plug in a 4 now to that, and you have 1 over 6 after you cover up the x minus 4. Oh, no. Go away. I want to make that go away. There it goes. And then do the same thing for the negative 2. You get negative 1/6. Both of those are ln problems. Negative 1/6 ln of x minus 4 minus 1/6 ln of x plus 2 from 0 to 1, which you could go ahead and evaluate just like that. But I went ahead and made it into a single fraction first because it's subtraction from 0 to 1. So you plug in 1 and you get a negative 3 in the absolute value, and you get a negative 2 in the absolute value, and it's very important that they're an absolute value because you really can't take the ln of a negative number. So when you combine them, you end up with 1/6 ln of 3/2. If somebody stopped here and just said 1/6 ln of negative 3 without absolute values, minus 1/6 ln of negative 2 without absolute values, that is a wrong answer because that does not exist. You could stop right here as long as you have the absolute values. But if you did not get to the point where you show that it's a positive 3/2 because of the absolute values, then you will probably not get credit for that. So that's the end of part B. For part C, for k equals 1, find the value of 0 to 2 f of x dx, or show that it diverges. So that means it's probably going to be an improper integral. So when you plug in 1, you get x minus 1, the quantity squared, which means the graph does not exist at 1 and the interval goes from 0 to 2. So that means that at 1 we got a problem. I've got a picture of the graph right here. Since f of x does not exist at x equals 1, you've got to use improper integral. So what you must do is integrate from 0 to 1, and then if you get an answer to that, then you can do 1 to 2. So let's start out with 0 to 1. Since 1 does not really get there, I do a limit as b approaches 1, integral from 0 to b of x minus 1 to the negative 2 power. Once again, it's not an ln because of the fact that the exponent on the bottom is not a 1. So we raise the power, put the reciprocal in the front, evaluate from 0 to b. So we have, I rewrote it back on the bottom before I plugged in. The limit as b approaches 1 of negative 1 over b minus 1 plus negative 1 over 0 minus 1, and lo and behold, that is negative 1 over 0, which does not exist. Therefore, the integral does diverge because I got a D and E answer for my integral. All right, that's number 5. Moving on to number 6. And number 6 is kind of a rather large graphic here, so I'm trying to keep everything in the screen. I have a function f that has derivatives for all orders. Portion of the graph is shown above, along with line tangent at 0. Selected derivatives of f at 0 given in the table. And I told you there would be a Taylor's question on the test, and here it is. Write the third degree Taylor polynomial about 0. So the first thing I did is I wrote the formula. There it is. P3 of x, f of 0 over 0 factorial, f prime of 0 over 1 factorial, x to the first, f double prime of 0 over 2 factorial x squared, f triple prime of 0 over 3 factorial x to the third. So you need all of those. Now f of 0 you get from the graph. F of 0 is 3. And f prime of 0 is the slope of your tangent line, which happens to be negative 2. After that you go to the chart. So we have 3 and then negative 2x, and then 3 is your numerator over 2 factorial 2x squared, negative 23 halves over 3 factorial, which is 6, x to the third. Now you could have left those as 2 factorial and 3 factorial if you wanted. Later on you're going to need them simplified anyway. So if it's cleaned up, this is what it turns into. 3 minus 2x plus 3 halves x squared minus 23 twelfths x to the third. That is the Taylor polynomial. All right, part B. Write the first 3 non-zero terms of the Maclaurin series for e to the x. Write the second degree Taylor polynomial for e to the x f of x about 0. So this is why I told you needed to memorize the e to the x sine and cosine. So e to the x is 1 plus x squared over 2 factorial. The second degree polynomial for e to the x f of x about 0. So f of x, you just take second degree here, 3 minus 2x plus 3 halves x squared, the first 3 terms from up here, and they just want you to multiply them together. The one thing you've got to notice, however, which I didn't the first time I did this problem, it says second degree. So anything that creates something above a power of 2, you throw it out. So when you multiply it together, you multiply the 1 to all 3 things in here, which gives you a degree of 2, 3 minus 2x plus 3 halves x squared. Then you multiply the x in. So that's going to give you x times 3 is 3x, x times 2x is negative 2x squared, x times that is going to be x to the third, so I don't do that. And then I take the final term, x squared over 2 times 3 gives me this. X squared times this x, that's too big. The last 2 is too big. So that's all the terms I need. And so I stacked them so I could combine like terms quickly. 3, positive 1x. Adding those up, you get a positive 1x squared out of that. So there's your answer. All right. Part C. Let h be the function defined by h of x as the integral from 0 to x of f of t dt. Use the Taylor polynomial found in part A to find an approximation for h of 1. So that, of course, means that a 1 goes in for x here and for x there. So there's h of x, so we plug in 1, 0 to 1. We use the Taylor polynomial we built before. It's in terms of t. And then we just take the antiderivative of it. So it's 3t minus t squared, 1/2 t to the third, 23 over 48 t to the fourth. from 0 to 1. Plug in 1 for all the t's. Plug in 0 for all the t's gives you 0. You do not have to clean it up. I would stop right there and save yourself the trouble, because if you make a mathematical error, you'll lose the point for the answer. So just stop right there. Hopefully you did. And then finally, part D. It is known that the Maclaurin series for h converges to h of x for all real numbers x. It's also known the individual terms in the series for h of 1 alternate in sign and decrease in absolute value to 0. Use the alternating series error bound to show that the approximation found in part C differs from h of 1 by at most 0.45. Now this was the one topic that really was our nemesis this year, was error. So hopefully some of you were able to get this. It fits all of the qualifications for it to use the alternating series error bound. It decreases, it alternates in sign, and it converges. So the series for h of 1 is alternating, so the alternating series error applies. Now in retrospect, I believe I needed to write down, since the series for h of 1 fits all of the criteria for alternating series, that the alternating series error applies, and the error is the next term in the series. So the formula says that the next term in the series would be, since h of 1 was an integral, the next term would be the integral from 0 to 1 of f to the fourth derivative of 0 over 4 factorial and t to the fourth. The fourth of 0, if you go back to the chart, is 54. So 54 over 4 factorial t to the fourth dt, we're integrating. And if you integrate that, it becomes 1/5 t to the fifth with the 54 taken out. So instead of 4 factorial, that 1 over 5 makes it into a 5 factorial. T to the fifth from 0 to 1, so you plug in the 1, and you get 54 over 120, which happens to reduce to 9 over 20, which happens to be 0.45. And there's where your 0.45 comes into play. So that is the end of all of the AP questions. Hopefully you did well. I will see your scores when they come out. That will be July the 6th, when you can go online and check your scores and see how you did. Have a great summer, and thanks for watching.